Hello all. So my name is Islas Nawaz. I'm just going to be running you through an LLM that I've created. For high level intro, my name is Islas Nawaz. So Forge LLM, initially I did change it to Islas LLM. Essentially, it's a self-hosted chat app I built to run entirely on my own hardware. So there's no external APIs, there's no data leaving the machine. Inference runs locally on an Apple Silicon Mac, which I'm currently using through MLX, and the whole thing is saved behind a Cloudflare Flare tunnel at obviously slash-ai.com. So the stack is intentionally small. Fast API on the back end, vanilla JavaScript on the front end with DOMPurify and marked.js rendering, SQLite for storage, and a Cloudflare tunnel for obviously public access. There's no build steps, no framework, no node module. So the default module is Quen 2.5 7B instruct. So and this is quantized to 4-bit. So it downloads from Hugging Face on the face run around 4 gigabytes and then lives in memory after that. So the interesting part is here. So the core problem is this. So MLX is a stream generator is quite synchronous Python generator. So it blocks. So Fast API runs on an async event loop. So if I call, let's say, stream generate directly, um, if I call stream generate directly inside the WebSocket handler, the entire server would freeze for the duration of every response. So no pings, no stop signals, no other connection. So the fix I actually had here was essentially just to essentially thread plus a queue bridging the sync and async wheel. So I run stream generate inside a daemon thread. So as the tokens push out, the thread then pushes them into a async io.Queue, and this obviously uses the call soon thread safe, which is obviously a safe way to kind of talk to an event loop from another thread. So on the async side, the event loop drains that queue, and then with obviously a 10 millisecond flush interval, batches the tokens and then sends them down the WebSocket. So the result is essentially that the event loop is never blocked. The pings work, mid generation, and the stop button also works. So multiple connections work. The model just streams into the background. So there's one bug worth calling out though, because it's kind of like a thing that looks quite fine on paper. So the first version of the token collector actually polled the token queue first. And then it actually checked for the control messages. So the problem is that when the model was obviously is generating fast, the token queue is always full, so the control message queue, the control message check only ran once per token, which meant a stop signal could sit in the queue for dozens of tokens before processed. So you'd press stop and the model will keep going. So the fix was just to check the control queue first, at the top of every loop iteration, and I did that with the get no wait, and the try except, so that essentially, you know so it doesn't block it. So I then waited on the tokens with a short timeout. So now the stop is processed at the start of every iteration before any token work. I only caught it by actually pressing the stop button during a long generation. The code actually looked correct on inspection. The two other things of the pipeline that I like to point to as well is, first, the smart title generation. So after the first exchange in a new conversation, the model actually generates its own title. So first words or fewer, low temperature, and this is capped at 12 tokens. And this is fired as a background task that shares the same generation lock. So it never actually races with active generation. So the task is actually pinned to set to prevent garbage collection killing it mid-flight, and which is quite a small thing that catches people out with, again, that async io.create task. And obviously the another thing was essentially the KV cache pre-warming. So when you open an existing conversation, the server actually runs one token of generation against the history to essentially pre-populate the MLK's KV cache. So if the model is busy, it then gives up after half a second and lets the first real message do the pre-fill naturally. The user facing the effect is that they're returning to a long conversation feels instant instead of pausing for 2 or 3 seconds. So the prompt builder was actually one optimization worth mentioning was essentially Quen 2.5 actually supports 32K context. So, but I actually copy at 8K to leave room for the response. So when history exceeds that, all these messages get dropped. So the cheap approach would be to essentially re-tokenize the full prompt after every dot message, which is O n squared. Instead, I actually estimate per message cost once upfront. So I then trim using the estimate, and then I do a single verification pass with the real tokenizer at the end, and that's for one full tokenization instead of n. So that's from a high level, right? So kind of going into the middleware now. So the middleware is in main.py, and essentially here, this sets all of the standard headers. So we're talking CSP, HSTS, X-frame options, the permissions, policy, the lot. So auth is actually session cookie based and gated at the middleware level. So every non-public route is protected by default rather than per endpoint. And obviously I use rate limiting here because it works at two levels. Per user message limits to essentially stop one account handling the model, and then of course per IP WebSocket connection limits to stop any connection storm attacks. Both windows again clean themselves up every 5 minutes. So again, I use cloud code throughout. The thread plus the queue pattern came out of a back and forth. So my first step, again, I was mentioning, was through that async the io. I say async the io.to on the thread, and around the stream generator as well. So which works, but essentially blocks. But it blocks it until the generation finishes, killing the stream. So the thread plus a queue was suggested in that conversation. The security headers, so the dual pass context trimming and the rate limiting design, all essentially all worked out the same way. So the stop signal bug I mentioned earlier, that was obviously AI generated code, and that actually looked right at the start, but it failed in practice. The fix actually came from testing, not from reading the code. Um, yeah. A few delivery notes. The bug obviously worth mentioning is obviously the strongest part. And yeah. Let me just look. In case anything else so in the index the HTML, essentially I've got a dialog. I've got dialog ID with feedback model. Essentially, it's closed with a div. Browser recover, but it's invalid and it could break the dialog semantics and stricter passes. So I could probably have a probably stricter, probably stricter passes. Probably look into that. In the loader.py, in the model dot make, in the model model dot make, yeah, cache. This obviously doesn't exist because I did flag this earlier because MLX models don't have a dot make cache method. The correct call would just be essentially sorting out by actually calling it at the top level and returning the make prompt cache. So right now the essentially the attribute error branch swallows it, and then you get none, which means essentially KV cache is none everywhere. The prompt cache quag is never actually added to the gen quags, and the pre-warm and pre-fill history is actually doing nothing useful. It just generates the token and throws the cache away. So the whole instant return to long conversation feature is slightly disabled. Thinking now what else to kind of go through. So yeah, so in the handle message, so if rec is none, essentially here, the function signature is tuple. But if rec is none, you essentially have sent an error there on the front end, but it's still showing typing dots forever. The end generation essentially here is never called because no done or error event with the right shape arrives. But then same function rate limit path also returns early. Uh, do, 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 looking at the DB. So this is module level connection. This is a single AI SQLite connection shared across all the requests. So essentially all this does, yeah, it just serializes everything through one thread. So on the load, you'll have this, I'm gonna have the same request queuing on the same connection. So I think for this app it's okay, but let's say we had concurrent users, so obviously my rate limiting allows 30 connections per IP minute. I'll see latency spikes on DB writes during active generation. Also, one thing I did actually notice, right, was the on the await on the db.commit, what I did see was it happens every single add message, so including during the streaming as well. Um, each commit is obviously f-sync with, it probably could be with batching up or at least dropping that synchronous to normal to synchronous off. Um, yeah, so probably update this to synchronous off if I probably accept that durability trade off. I've already got the wall anyway. Um, so this is obviously from the UI. I'm just gave it a prompt saying hi. Just to kind of, obviously I'm running it locally on the port 8000. Yeah, as you can see. So in the .env, I've actually made it so it's actually a more of a personal assistant. So yeah, so that's on a high level. Thank you for watching.